Welcome to Sundar's lecture. This is lecture number 21, and in this lecture we are going to see decoders with enable inputs, and then we are going to see what is demultiplexer and encoders, right? So what are all the topics we have seen in the previous class? See, we have started with the decoders, right? And also we have seen how to implement a full adder using 2x1 multiplexer, and we have gone for decoders, and we have seen what is 2x4, 3x8 decoders, and we have seen what is inside the decoder, the logic diagram of the decoders, and then we have tried to implement the Boolean functions using the decoders. This is how we have implemented. Right now, we will see a different one, like a decoder with enable input. Like normally decoders have one or more additional input line that referred to as enable inputs. And what is the purpose of this enable inputs and how it is going to help us to implement a 4 variable Boolean function with 3x8 multiplexes. That is also possible now. But see, in the previous examples, this is actually 3 input system, because you have different 7, 8 different combinations, right? So you have, this is a 3 input system, but we have used a 3x8 decoder. Like the same here, we have done this one, right? But what we are going to do today, we will have 4 input system, and we are going to implement that with the 3x8 decoders. And how it is possible? That is the uh, idea we are going to see in this particular lecture. Right? This is a 2x4 decoder with enable input. How it looks like? For example, like we know this one, right? So this is the decoder. This is 2x4 decoders. Try to understand. So if it is 2x4 decoder, what happens now? So you will have 2 inputs. This is just one. This is the second input, and you will have 4 outputs. You know these kind of things. This is what you have seen in the previous class, right? This is what you have seen in the previous class. Now, what happens now? You will have an extra input line like this, and this is now, maybe you take this as x0, x1 as the input, and we will take the output now, whatever it may be, z0, z1, z2, and then z3. This may be taken as y1, y2, y3, y0, y1, y2, no problem, right? Now you will have an enable input. This is the enable input now. These two are the input lines. These two are inputs, and you know these. This is output. We know these type of things we have already seen. And what is this one now? It is 2x4 decoder. Right? This is a 2x4 decoder. And now, what is the truth table? Truth table for this one, I will just draw it down. Right. Now, this is the truth table. This is the truth table. See here, we will have a enable now here. What is the 2 input system? So you have, right. So this is now 0 0 0 1 1 0 1 1. This is, you know, already, right. Now what happens here? If this enable is 0, whatever the input you have, all the outputs will be 0. This is the whole idea. If you give 0 to this enable input, then whatever the input you give here, this makes output to 0, all the output to 0. That is the whole idea. Now, then this enable has to become 1, so that this multiplexer will work now. Otherwise, it will not work, right? So, now if it is 0 0, then if I give 0 0, then this Z0 becomes 1. This becomes 1 and all others are 0. Likewise, right, then if you give 0 1, then the 1 will be enabled, all other outputs become 0, and 1 0 is at 2 will be enabled, and all other outputs will be disabled, and for 1 1 it will be like this, right? So now this is the truth table, right? Can you understand what is the 2 cross 4 decoder with enable input, right? So if enable pin is 0, then whatever you give input, either it is 1 or 0, whatever it may be, the output defaultly become 0, right? No, now this is the diagram. This is the diagram. Inside the diagram, you will have inside the decoder, that means with the enable input decoder, you will have like this now. Now what happens? This enable input will be connected to all the, right, now it will be connected to here, and this will be connected to this one also, this will be connected to this one, this will be connected to this one. And what is this one now? This is z0, z1, z2, and then z3. For example, if you make this e to 0, if you put e to 0, then what happens now? This this will be 0 in all the AND gates, and whatever you give input, that doesn't care about anything. The output will be defaultly 0 because the enable is 0. And for example, if you give E is equal to 1, then what happens? This all AND gates will get 1, 1, 1, 1 here. And this one, if you give 0, 0, so for first one, x is equal to 0, and then x1 is equal to 0 means x0 bar is 1 now, so 1 will come here. X1 bar is 1 now, 1 will come here. So this is now 1, 1 already enabled is 1. So this output becomes 1. Another output becomes 0. You can cross verify this one. So this is the logic diagram of a decoder with enable input, right? So this enable input makes the whole decoder to all the outputs of the decoder to 0 if it is 0. If it is 1, then it will be a normal decoder, right? So that is the whole idea. Now, this is the very important thing. Implement 3 cross 8 decoder using 2 cross 4 decoder. How it is possible now? How it is possible? That is the idea, right? So this is actually a min term, right? So for example, you take this as min term 0, min term 1, min term 2, min term 3, min term 4, 5, 6, 7. Right? You have 8 outputs, like 8 outputs, right? So not min term, you can take it as outputs, right? So what is happening around here? Now this is actually a 2 cross 4 decoder. This is another 2 cross 4 decoder, right? But you have 8 inputs now. What happens if you give 0 0 0, then m0? That means this min term, this is min term. I am taking outputs as min term here. That's all, right? This min term has to be enabled. How it is possible now? That is the whole idea. You have to understand it clearly here, right? What you do, you put a NOT gate here. See here, one thing. This is actually ABC input, not x0, x1, what we have taken in the previous example. So what you do now, you take this as B and then this as C. Don't do anything with this. And also the input of this one is B, input of this one is C. Take like that, right? Now you have another input A. You have another input A, right? Now what you do, you just take this A, hmm, put a NOT gate, connected to this one, and this is now A bar, right? Now what you do, you just put this A straight away to this one, and what is this now? This will be now A. Can you understand? Now what happens? Let us assume this as a 3 cross 8 decoder. How? See this one. What is this one? This is a enable input. This is a enable input. Right. Right. Can you understand? So now we have done this one. Now what you do? You give 0, 0, 0. What happens? A is equal to 0 and B is equal to 0 and C is equal to 0. If you give 0, then what happens here? This will become 1. That means this will become 1. So that this enable pin is equal to 1 here. If enable pin is 1, then this decoder is enabled, which means this is now going to work. And if you give 0 to this one and this 0 has been given to this decoder now. Now this is 0 and whatever you give input, that does not going to care about the outputs, right? The outputs does not going to care about the input whatever you give, because this enable input is 0 here. So this is not going to be, this decoder is now disabled. Now it is not going to work, right? So the thing is, now you give 0, 0. So this is now enabled, right? This is now enabled. So you are giving 0, 0 to the inputs. If it is 0, 0, then minterm, that is this output will be enabled. That is what you are giving here. And if you give 0, 0, 1, that means 0, 0, 0, 0, 1, maybe the A is 0 now and B is 0, C will be changed to 1 now. And for all A0, this decoder will not be enabled. For first 4 inputs, this decoder will be disabled, obviously. So now 0, 1, 0, 1 means then this output will be enabled. That is what I am getting as minterm 1. Can you understand? Can you understand? So likewise, you give 1, 0, the A is 0, obviously 0, 1, 0. So if you give 1, 0, 2 will be enabled, and if you give 1, 1, 0, 1, 1, then 3 will be enabled. And what happens when this 1, 0, 0 has been given? So now if this is 1, now this will be 0 and this will be 0. What happens to this one now? This will become now 1. Try to understand. If this is 1, this is 0, then this will be disabled. This will be disabled, obviously, right? And this will be enabled. 1, 0, 0, right? So you will have 0, 0 here now. So if it is 0, 0, then 4 will be enabled. This is disabled. 0, 0 given, 4 will be enabled. That means the output 4 will be high. Which means enabled, it is high. Now, if you give 1, 0, 1, 1 means this decoder will not work. So 1, 0, this becomes now 1. So 0, 1 means 5, and then 1, 0 means 6, 1, 1 means 7. Can you understand? Can you understand? This is the whole idea. What we have done here, we have just implemented the 3 cross 8 decoder output. This is actually 8 outputs are there. You have A, B, C inputs, right? We have just executed this truth table with this 2 cross 4 decoder, right? So this is actually the truth table of 3 cross 8 decoder, right? So this is how you need to implement, right? Can you understand this whole idea, right? This is the implementation of 3 cross 8 decoder using 2 cross 4, right? What is the next one? You have to implement full adder using 3 cross 8 decoder and as well as 2 cross 4 decoder. 3 cross 8 decoder, it is very easy, not a big deal. Now we try to do that, right? So this is sum and this is carry. You know the truth table of the full adder, and we are going to just implement for this is using 3 cross 8 decoder, right? So 3 cross 8 decoder, what you will have, right? So this is now the decoder, 3 cross 8 decoder, right? So you will have 8 outputs, right? 1, 2, 3, 4, 5, 6, 7, and then 8. And you have 3 inputs, 1, 2, 3. So these 3 inputs are A, B, and then C. What is this one? This is 0, 1, 2, 3, 4. This is 5. This is 6 and this is now 7. And if you want to get it for sum, what you need to do, you have to see 1 and 2. You have to put an OR gate here. Put an OR gate. Put an OR gate. This is for sum, right? And put another OR gate. Put another OR gate. This is for carry. Try to understand. This is for sum, and this is for carry. And what you need to do now? What you need to do? Just connect this thing. So 1, 2 has to be connected. 1 has to be connected. 1 has to be connected, and then 2 has to be connected, and 4 and then 7, right? So 4 has to be connected, and 7 has to be connected. Right? This is input. Try to understand, right? So anyway, I will just put down. So this is also an input. 7 has to be connected, and you need to connect this one, which is the carry. That is 3 has to be connected, right? So 3 is one input. So 3 is one input, and 5, 6, 7. 5, 6, 7. So 5 and then 6 and then 7. So now what happens? What happens? This is now sum and this is now carry. You will get the output, right? If you give 0, 0, 0, then this will be 0, this will be 0. And if you give 0, 0, 1, you will get the sum and carry. It is very simple, very easy to. This is 3 cross 8 decoder. This is 3 cross 8 decoder. Even if you have an enable input, if you have enable input, you give that enable input to here. This is enable input, right? So this is enable input. What you have to do, you have to put this enable always 1 for all the inputs. For all the inputs, you keep this enable to high. That is the idea. You don't do anything with this enable input if you are implementing the full adder using 3 cross 8 decoder. It has to be high. That is the idea. Right now, what we will do, we have to implement using 2 cross 4 decoder. What will you do now? You have to take two cross 4 decoders. That's all. Very simple. Right. Now you see, I have just taken 2 cross 4 decoders to implement the sum and carry. Very simple. Here also you have to do the same thing. What you do now? You just draw an OR gate, for sum. This is for sum, and you draw another OR gate, and this is for carry. This is for carry. This is for sum, and this is for carry. What we have done, we have just already seen right here how to implement a 3 cross 8 decoder using 2 cross 4 decoders, right? That is what we are using here. Now it is very simple. You just connect them 1 2 and then 4 7. 1 2 4 7. So this is 1 1 1 should be connected, 2 should be connected, 2 should be connected, and 4 7, right? 4 7. This 4 has to be connected, and then 7 has to be connected. You just connect like this, right? This is connected. And for this one, which one? This 3 5 6 7, right? So 3 5 6 7. You need to connect 3 5 6 7 straight away. This is 5, this is 6, and this 7 has to be connected. Now this is the output of a full adder using 2 cross 4 decoders, right? Can you understand? You just with the truth table, you just give this values and and try to find whether it is working correct or not, right? That is you do by yourself, right? Now you listen. We are going to implement 4 cross 16 decoder using 5 2 cross 4 decoders. For example, if you are going to implement 4 cross 16 decoder using 3 cross 8 decoder, it is as simple as this one. Draw two 3 cross 8 decoder, you will have 16 outputs and you will have 3 inputs in one decoder, 3 inputs in another decoder. You make that as BCD, BCD. For A, you give like this. One is complemented, the other one is a direct A. Try to understand, right? That is very simple. I'm not going to do that because you have a basic idea about how to implement a 3 cross 8 decoder using 2 cross 4 so that you can easily do 4 cross 16 decoder using 3 cross 8 decoder. That is very simple. But what I'm going to do, I'm just going to implement 4 cross 16 decoder using 2 cross 4 decoders. That is what I'm going to do. Just to give an input about how an enable input is working around in a decoder, right? That is my whole idea. Right. What you have now for 4 cross 16 decoder means you have 4 inputs, right? So you have x0, x0, x1, x2 and then x3. These are all 4 inputs you will have and you will have 16 number of outputs, right? So 16 number of outputs means from Z0 to Z15. I'm not going to write everything. It will be clumsy, right? So what is this Z0? What should be this one? This is actually the, like I have already told you, this is a decoder is a conversion of binary into a min terms. Right? This is the first min term, second min term and up to 15th min term. Right? So what is this min term has to be? It should be x bar, x0 bar, x1 bar, x2 bar and then x3 bar. Right? Like that, if you write up to Z15, what you will have? x0, x1, x2 and then x3. Like in mid you have different bar, different conditions you have. So this is how you will have. So what you do now, simply you give input as x2, x3 common to all this one, because you are going to give these 4 inputs. I am just giving here. This is, I will explain you bit later. I will explain you how this will work, right? So this is x2, x3. This is x2 and this is now x3. And what you do now, you make this to be x0, make this to be x1. Simply. Now what you have to do, you will get this one, right? So what is this one now? So this is this input, right? This input, this output, you just connect it to this enable pin straight away, right? Now what you do, you take this one, you take this one and you give to this enable. And what you do now, you take this one, oh, maybe like this, and you give to this enable input. And what you do, the next thing, you connect this one to this enable input. That's all. Now what you do now, you have another enable will be here, right? So what you have to do, this enable input, this is given to logic 1, simply you have to give it to logic 1. That's all. Now what you have to do, see, I will write it down here because I have space here. See, if I give x0 is equal to 0, x0 is equal to 0, x1 is equal to 0, x2 is equal to 0, x3 is equal to 0, which means I am giving all the inputs as 0. Which output should be selected? Z0. And if I give 0 0 0 1, then Z1 has to be selected. And if I give 0, maybe I will write it down all the outputs. See here, I have just written all the outputs, right? So now what happens if I give 0 0 0 0? Right, try to understand. I will put now this is 0, this is 0 and this is also 0 0 0 0 0 0, this is 0 and then this is 2 0. Can you understand what has now happened? So I will write down this one. Now, if I give 0 0, because enables are connected to this decoder, if I give 0 0 here, what happens now? If I give 0 0, this will be 1. All others will be 0, right? Can you understand? All others will be 0. Then obviously what happens if this is 1, then this is connected to this enable input now. So this enable input becomes 1 here, right? This enable input becomes 1 here. So if this is 1, what happens now? If this is 0 0, then obviously the Z0 becomes 1. Z0 becomes 1. And this is 0, so this decoder will not work. This is 0, this decoder will not work. This is 0, this decoder will not work. This is, I have given this one to logic 1, so this is enabled. So now what happens now? I am giving 0 0 0 0 and I am getting Z0 output as 1. All other outputs become 0 here. Can you understand? So same thing if I give 0 0 0 1 now. What happens? What happens? Now this is 0 1 now. So this will be now 1, right? Instead of the 0, I will have 1 here, 1 here, 1 here, 1 here. Which means I will give the x0, x1 is 0 0. So obviously this will be 0, this will be 1, all other enables are 0. So every decoder will not work now. All these three will not work. What happens to here now? It is now 0 1. If it is 0 1, then what happens? This Z1 will be now 1. This Z0 becomes 0. Can you understand? Because this is 0 1. Likewise, you give all the combinations. What happens now? You will get for first 0 0 0 0 you will get Z0, 0 0 0 1 you will get Z1, 0 0 1 0 you will get Z2. Like that you will get for all outputs, for all the inputs, right? You will get separately one output will be enabled. So everything is a 2x4 decoder, right? So this is how this is actually working, right? We have implemented. We are getting 16 4x16 decoder output by using only 2x4 decoders, right? So the implementation of Boolean functions will be very simple now. If you see any minterms, maybe Z5, Z6, Z7, Z8 are only 1, all other outputs are 0, then you connect all this one to a OR gate and put an output. That's all. Very simple, right? This is a common diagram. Right? You have to understand, right? So what are all the topics we have seen in this class today? See, we have started with the decoders with the enable inputs, right? So what happens if you have a decoder with enable inputs? So if this enable input is 1, then only the output will be enabled. For enable is 0, then whatever you give as input, the output will be 0. That is what I have told you in this one. And we have seen what is inside the decoders, the logic diagram, and then we have implemented to a 3x8 decoder using 2x4 decoder, and we have also implemented full adder using 2x4 decoders like here, and then we have gone to implement 4x16 decoder using 2x4 decoders, right? So we have just implemented here. So we will see in the next class what is demultiplexer and then encoders. That we will see in the next class, right? Thank you.